All right, so on example 10 is not a geometric problem. It's not something that we can kind of draw on label sides, come up with equations by using geometric formulas. It's a situation. So reading the situation, let's see first of all why it's optimization. It says the manager of an 80-unit apartment complex. So if you haven't figured it out by now, I'll tell you what I tell my daughter. She's in 7th grade. When you have a word problem, put yourself into the problem. Now it's about you, and it's like something you actually have to do. It makes the problem, if not easier to solve, definitely more fun, right? So congratulations. Y'all are now managers of an 80-unit apartment complex, right? Yeah. That was a little pride, right, in your job. You want to do a good job? All right. You're trying to decide what rent to charge. Okay? You're trying to decide what rent to charge. Experience. The previous manager who got fired, that's how you got the job, kept records, detailed records. And the data that he kept, or she kept, shows that at a rent of $200 per month, every single one of the 80 units is going to be full. You're going to have complete 100% occupancy. You, wanting to get manager of the month, right, want to maybe increase the profit of this complex. So if you raise the rent, what happens to the units? Will people continue to live there? If you raise the rent to $2,000, will all 80 units be full? If you raise it to $200,000, will all 80 units be full? There comes a point where you're charging too much, you're going to have some vacancies, right? So I'm not sure if these numbers are really relevant for today, or if they are where this is happening, or if these numbers are more relevant to maybe like in the 1860s, where this was like a high-end place to live. We don't know. We're just using it for demonstration purposes. On the average, though, here's what we know. For every $20 increase in the rent, there's going to be one person that says, too rich for my blood, I'm leaving, and that unit will not get rented back out. It'll be vacant. Okay? Now, it seems almost counterintuitive, then, that you can actually have more revenue generated coming in per month by having fewer apartment units being rented out. But that might be the case. Okay? So let's see what we have. This is not something we could draw, right? You could draw like an apartment complex and maybe draw a horse outside, right? There's my horse. See? But that's not going to be helpful. So let's just see what we currently have now. Let's just say if we charge $200 now, how much revenue we're bringing in. How are we going to compute that? 80 units, each giving me $200 per month. That's going to be 80 times 200, right? And that should be $16,000. So if I did charge $200, I know all 80 are going to be filled. I'm going to get $16,000 per month, right? Which it's all mine, right? Because I'm the manager. That's how it works. All right. Well, I can do a lot. I can do a lot with that $16,000. Yeah, you take it and run, and that's called embezzlement. All right. What's the variable here? What should we do next? We're trying to see a pattern. What should we do? We're just playing with numbers instead of people's lives right now. 80 minus n? Yeah, let's just try raising it one time. Let's try one increase. Let's see what would happen. Just kind of like on paper, right? If I increase it by 1, then I'm going to have one person leaving, right? So my new number of tenants would be 79, or 80 minus 1. What would be the new rent to charge? Yeah, 220, which is 200 plus 20. Or 1 times 20, right? It's one increment, 20. Okay, so let's see. That ends up being 79 times 220. And I need some help with some people with a willing attitude, a can-do attitude, and a calculator to type that in. 79 times 220. Thank you so very much. There you go. So as a manager, you'd be like, man, if I assume that that's true, raise it 20, only one person leaves, this is win-win for me, right? Because not only am I getting more money per month, but I have one less tenant to deal with. Thank you very much, right? Yeah. Well, if I could do it once, can I do it twice? Well, let's see. Let's raise it twice. 2 increases. Now I'm going to have 78 people, also known as 80 minus 2. My new rent to charge is 200 plus 40, yeah, or 2 times 20. So it ends up being 78 times 240. Nice. If this keeps up, we're on a roll. We're getting more money every time. So let's see. Will this happen indefinitely? What if I raise the rent 80 times? Because, man, every time I do, it goes up. Well, let's see. Then I'm going to have 80 minus 80. That's going to be how many tenants I have. And per month, the rent is going to be 200 plus 80 times 20, which I don't need a calculator for that because that's 0. Well, the good news is you have no headaches because you have no tenants to call and complain about something. But the bad news is you also have no job, right, because you have no tenants. So here's what I do know. I don't want to raise the rent 80 times, 80 multiples of 20. But apparently, because this is happening through a continuum of positive increases for integers, it starts at 16,000 and it goes up and then it comes back down to 0. So I know by the MVT that there has to be a place where the slope is 0, and that's going to be where I have a maximum profit or revenue at least coming in. Maybe it's not all profit. And I want to find it. So at this point, since we're counting by positive integers and not real numbers, you could find that answer by completing the table, right? You can see how much revenue you generate for all 80 increases and then pick it out of the lineup. But that's going to take a lot of time, and you have other things to attend to, right? Like making sure the pool is clean and unclogging that toilet in apartment 73. So let's try and be quick about this. Let's use the power of calculus, which is the fastest way to get employee of the month. We need to establish a pattern. Brandon, you almost had it in the beginning. Good. And what are you defining n to be? Defining your variable is important. It's the hashtag of increases, right? Hashtag is kind of taken over the pound sign, which used to stand for a number. The pound sign used to mean number, and now it's hashtag. Why do they call it the pound sign, and why did it mean number? Anyway, it has multiple purposes. Yes, the variable is not the current rent, but the number of increases. And mathematicians, if they're nothing else, are pattern recognizers. So if I would have just thought about the sequence and used those numbers there, 79, 220, 78, 240, I wouldn't necessarily see the pattern, right? But by writing it like this, 80 minus 1 times 200 plus 1 times 20, 80 minus 2 plus 200 times 2 times 20, I can actually see my variable over here, the thing is changing. I can see that number in the calculations. And so what I can do then is come up with a formula in general as a function of what you called n. So I'm going to let R, big R, be the revenue as a function of n, the number of increases we're going to have. And, of course, now the pattern should be obvious. It's going to be 80 minus n. And that should give us the number of tenants. And that's ANTS, not ENTS. That's different. And then the rent to charge is going to be 200 plus 20N. Good. That'll be the rent. So now we have a function, a formula, and of course n in this case is going to be an integer. Between what? What are the upper and lower bounds? 0 and 80. And in this case, can we technically include the endpoints? Yeah. We can raise, bless you, the rent 0 times. And we could, if we wanted to, get employee of the month not, we can raise it 80 times. But we know the solution is going to be on the interior. Okay, so now we need the critical value. We need the derivative. You want to expand and use the power rule or just use the product rule? I'm just going to use the product rule. Yeah. So we get negative 1 times 200 plus 20n, and then plus 80 minus n times 20. Product rule. We set it equal to 0. Now, you could factor out a 20 if you wanted to from each of them. Do you want to, or do you just want to expand it out? What would you be more likely to do? Once you set it equal to 0, you don't need to keep it equal to r prime. Expand it? Let's expand it. the numbers are pretty manageable. Negative 200 minus 20 yen, and then we're going to have a plus 1600 minus 20 yen, and that equals 0. So we have a negative 40 yen equals a 1400. So if you separate them, you get 40 yen equals 1400. Just doing kind of a couple of steps in one. So if you divide through by 40, you get 1440ths, which the trailing zeros divide out, and you get 144ths. And then 4 goes into 140 3 times into 14 with 2 left over. 4 goes into 25 times. So 35. Now, if you forget what N is representing, you might be like, okay, $35. Okay, so everyone, the rent's going to be now $35. And you get fired, right? 35. Because N is 35 rent increases. So now we have the optimal value. And by the way, notice if you were to expand your revenue equation, the leading term would be negative 20 yen squared, which means that your revenue function is the graph of a parabola opening down. So you know that the vertex is going to be not just the local max, but the absolute max. So 35 is it. So now we answer the question. It says to find the rent to charge. So the rent to charge is going to be 200 plus 20 times 35. And if this were a free response, you put dollar signs on the front and you're walking away. Right? But if you told your tenants that, some of them might not appreciate that. So let's go ahead and figure it out for them. 35 times 20 is going to be 700. Oh my gosh. Oh my gosh. So the new rent to charge is $900 a month. Now, as a manager, you have to inform your tenants. You got to send that letter. Dear tenants, for the last 20 years you've been living here, we appreciated your business, and we hope you've enjoyed your stay here. You've been paying $200 a month, which we realize now is you've been fleecing us on your habitation. So we are going to increase your rent 450% to now $900. We are the guy that bought that drug company or the pill that was used for AIDS patients, and he jacked it up from like $15 a pill to insane amount of pill. We're the manager, right? We're going to be unpopular, right? But this is in the name of corporate greed, right? We're after money. We don't care about people's lives. $900. Okay, deal with it. Get another job. Get a second job. Get a third job. Whatever. Okay? We're raising the rent to $900. Ugh. Okay, that's going to maximize the profit. Now, let's see how many people are going to leave. How many people are going to leave? 35. So, as a greedy now apartment manager, with 35 people gone, that leaves 80 minus 35, or 45 units are filled. Okay, and 35 are vacant. So you have fewer tenants to deal with. Now, that is where the problem ends, okay? But in the real world, somebody last period said, well, you know what? If that data is true, if only an increase of $20 is going to force someone to leave, then what if you raised the rent from $900 to $919.99? Now that person is not going to leave because it's not a full 20 increase, and everyone now is going to think they're getting a bargain, right? Because it's only $919.99. I can't believe it's under $920. I can't believe it. It's too good to be true. It's under $920. I can't believe it. $919.99. Woo! They feel like they're getting away with something. They might pay you more just for the benefit of having such a great deal. All right? So you could do that. And then what are you going to do? It seems like an awful waste just to have those 35 sitting there empty. Casino? You could do another business, right? You can call it Mr. Corpy's on the down low apartment complex, right? So you could actually turn it into a casino. I like that. Or it'd be easier since they're already fitted for apartments. You could just advertise, on the deep web. Yeah. I'm gonna only charge you $899.99 per month to live in those 35 vacants. Oh, then you got to do Bitcoin currency. I like it. Here's the thing, though. Here's the thing. You got to keep these other 35 people that are renting at a cheaper rate. You can't let them intermingle with the 45 that are paying the higher rate, because if they find out that now they're being charged a penny more, then you're going to have the makings of like a reality show for Bravo TV or something. Oh, that's construction costs. You're going to have to, yeah. Yeah, just let them all live together, right? Yeah, and their cats. Whatever. So anyway, after the fact, you can start talking about some interesting things. But the point of this problem is you have to look for a pattern, and it's important to understand what it is that's actually changing. What is your variable? Because the way you define your variable really affects the problem, the way you set it up, as you shall see in the next example. All right, questions on this? Nope. Nope. Okay, let's go to the next one. And here's the segue into the next one. It's fun to inscribe shapes into other shapes that circumscribe the inscribed shape we are inscribing. It's fun to do that. Example 12. Find the volume of the largest cone that can be inscribed inside of a sphere of radius 5. We're starting with the sphere of a given side, and we're going to put a cone inside of it. And that cone needs to be as big as possible. So, is this one that we could draw a picture for? Yes. Okay, so I'm going to show you my two-dimensional depiction of a three-dimensional sphere. And there's the center, and the radius is 5. It's a given size. We can't change it. It's immutable. Now, inside there, we have the power to put a cone. Now, the cone that is going to have the largest volume, I'm going to draw it like this first. Okay? It might live up here. Oops. It would be symmetric. Something like that. You think that cone is going to be the largest volume? No. But what I do know is that the cone, if it is largest volume, it's going to have its vertices on the perimeter or circumference of the circle. That's the cross-section of the sphere, right? Would you agree? But it might be one whose height is above the center of the sphere. It might be this tall one down here that's really tall and kind of narrow, right? It might be that one. Or it might be something in between. Yes. I'm not sure. Okay? It could be any one of those. Now, whenever you're not sure, it's kind of dangerous to draw an extreme case as your representative case. Okay? Something to label. So I'm going to get rid of this one up here. That's the short, wide one. And then the tall, skinny one I'm getting rid of. But here's what's interesting to note. If I were to take this short, wide one at the top and just start sliding these 2 points on the left and right up towards the top, what's going to happen to my shape as I go up to the top of the sphere? What? It'll collapse. It goes down to nothing. So the volume would be 0. Similarly, if I take that one here and I keep sliding it down all the way past the tall, skinny one, all the way to the bottom of the circle, what happens to the shape when it goes to the bottom? It gets collapsed down horizontally. So in one case, it's getting squashed down vertically. The height goes to 0. And in the other case, it's going to 0 on the radius. Both of those shapes are non-existent, so both of their volumes are 0, right? Which means somewhere between two non-existent volumes, there exists a positive volume. If it goes from 0 to positive back down to 0, there has to be one place where it's the biggest, right? It's going up and it's coming down. There you go. So we know it exists. Now, for a problem like this helps you visualize. My awesome 3D skills help you visualize. But it's kind of obscuring the real picture. So here's how I would recommend you deal with it. Just draw a two-dimensional cross-sectional representation of both your sphere and your cone. And I'm just going to draw a representative cone. Maybe you look like an equilateral triangle. That's what the cross-section of the cone looks like. Now here's the center of your sphere. Okay, I'm going to label the radius 5. That's going to be 5. This is going to be 5. And so is this. So I could choose to draw those radii anywhere, but I'm drawing them inside the cone as maybe it might be helpful when I draw that. Now here's another thing. You need to know the volume of a cone. That's what we're trying to maximize. And this is one you need to memorize. We'll use it a lot in the next section. The volume of a cone is pi thirds r squared h. The volume of cylinder is pi r squared h, and that's the one you're using in the homework, pi r squared h. So it turns out if you start with a cylinder and then you chip away 2/3 of it, you chip away a third of it, you take a third of it. You're chipping away 2/3 of it. Yeah, you're left with the volume of a cone. So the dimensions that we need for the cone are r and h. Now the radius of the cone, I'll draw here in brown. It's going to be this right here, and I think that variable's safe. The radius of the cone is not going to be the radius of the sphere. It's going to be smaller. The height, here's where it gets interesting. The height of the cone, you could call that whole thing h from top to bottom. I would not, though. It's perfectly legal. But then that little piece down there, if you called the whole thing h, you'd have to label as what? H minus 5. Good. And in general, when I'm working problems, you may be different. I don't like subtractions and I don't like fractions. So you run into those when you label big parts and then have to come back and label smaller parts within there. I'm not a fan of that, and that's not how I'm not going to teach you that way. There you go. Here's what I would recommend. Get in the habit of labeling your small parts, and then if you need to, you can build up to the big parts, and you won't have fractions either. Now, I'm not going to call that little piece below the center. I'm not going to call it h because it's not the height. I'm going to call it y because it's a vertical piece. And so now the height of my cone is what? Y plus 5. All right? Which it's plus instead of minus. That helps me feel better. So I need to adjust now my equation that I'm going to use for the volume. My volume is pi thirds r squared h, but now my h is y plus 5. So I'm redefining the variables by labeling a small part. And you'll see that's going to have added benefit here in just a second. It's not necessary. It's entirely up to you. All right, so now I have my equation to optimize, but it's in terms of two variables, both r and y. And so now I need to get the constraint involved, which is the sphere, and I need to somehow relate r to y and 5. 5 is the only quantitative number I have involving my constraint, the sphere. So if you go back to your diagram, can anyone see a way to relate r to y to 5? Pythagorean theorem, brilliant. You see that? Excellent. Yes, this little triangle down here is a right triangle because it's a right circular cylinder. And by the Pythagorean theorem, r squared plus y squared equals 5 squared. So it just so happens that whether it's a cylinder or whether it's a cone, the constraint equation is going to involve the Pythagorean theorem. So you'll have one in the worksheet where it's a cylinder. Now, if you had chosen to call the whole thing h, you could have used pi thirds r squared h for your equation. That's great. But this piece right here, as we already mentioned, would have been h minus 5. And then you would have h minus 5 quantity squared. And that's kind of gross, in my opinion. So that's why I choose not to do it that way. And you certainly can. You will get the right answer if you do it that way. Okay, so now what I need to do is I need to take my constraint and solve it for either r or y or r squared. I would solve it for r squared. Yeah, why not? So r squared is equal to 25 minus y squared. And if I needed to find the ultimate radius, I'll come back there at the end. Now here's where you do have to be a little bit careful. If you're plugging in for r squared, you're going to get pi thirds times 25 minus y squared. Guess what a real common thing to do is? Square that again. So just be mindful. Believe me, I've done it. It's easy to do. Times y plus 5. So now you have your volume in terms of a single variable, which is what we want. Thinking of a reasonable domain for y. The way I've defined y, I've got to be real careful here. I'm calling y the distance below the center of the sphere that I'm going to go to get my height. So what would be the maximum value for y? 5, right? What would be the minimum value for y? Actually, yeah, negative 5. Negative numbers here, actually, they kind of make sense. The way I've defined my variable, negative values make sense. I know I can't have a negative height, but if y is negative 1, that means that the optimal cone is going to have a height of 4, right? It's going to be 1 unit above. And I need to at least entertain the opportunity that could live above the center. Okay, now I do know that negative 5 and 5 are not going to be the answers, right? We've already explored that. They're not going to be the answer because they collapse. What's that? Sure, yeah, that would actually, I like that better. Because you can't have you can't have a height of 0 and you can't have a height of 5. It collapses it down. So both of those give you 0 volume, no shape. You could say it doesn't make sense. The key is that I know is that the answer is going to be on the interior. So let's take the derivative. I'm going to use the product rule, and I'm going to leave pi thirds just kind of hanging out there. All right? So here we go. We get negative 2y times y plus 5 plus 25 minus y squared times 1. And I'm trying to factor it because I want to set it equal to 0. So let's do that. Nothing in common, so I'm just going to distribute. Negative 2y squared minus 10y plus 25 minus y squared. We're just rewriting everything down. Pi thirds still hanging around out there. So we're going to get negative y squared minus 10y plus 25. And now if I set it equal to 0, I'm going to try and factor the quadratic. I'm noticing that my leading coefficient is negative. Not a big fan of factoring when it's negative. So let me factor out the negative and put it with the pi thirds. And now I'll have positive y squared plus 10y minus 25. Oh, yeah, thank you. Negative 3y squared, positive 3y squared. Because negative 2 minus 1 is negative 3. Yep. I'm looking at my watch, and I'm making careless mistakes. Ugh. Thief. Okay, thank you for catching that. Now I'm going to factor that, and I'm going to leave the pi thirds hanging around up there. You could technically multiply both sides by negative pi thirds and get rid of it because it's equal to 0. Remember, it's nice to have a full-fledged factored version of the derivative there. So let's see. This could factor into 3y plus or minus something because y is prime, or 3 is prime. And then it looks like 25, it's got to be the old 5-5 combo, right? And then if I need a positive sum, then I need to have a positive 15 and a negative 5. Yeah. So now looking at those, you could declare, maybe put them equal to 0 in your head. Y would equal 5/3, or y would equal negative 5. If you set them each equal to 0. But negative 5 doesn't make sense. It's not reasonable. And so there's the winner, positive 5/3. And so now that we have y equals 5/3, we can answer the question. It says to find the volume. So now I'll retreat all the way back here to my volume equation, and I'll plug it in. So the maximum volume is, and we're plugging into 5/3. So we get pi thirds times 25 minus 5/3 squared would be 25 ninths. If you want to square it, times 5/3 plus 5. And if we had more time, of course, we would maybe expand it out and make it look a little bit prettier. If you needed to find the height now of the cone, of course, once you have y, you can plug it back in over here to r squared equals 25 minus y squared. Find y, and then do what to get your height? Add 5. So it's not required that you label the small parts, but I think it's a little bit easier in terms of calculations because you're building up instead of subtracting or dividing. If you label big parts, you can also run into fractions. And fractions, huh? Do we have the y? Yeah, that's what we found. Oh, you're right. So what was I saying? If you need to find the radius, my bad. Yeah. If you need to find the height, you got to take this 5/3 and add 5 to it to find the height. Yeah. Okay, so we're done. We'll see you tomorrow. Have a great rest of the Happy to Pretend It's Time Travel Day.